All right. Hello, everybody who is watching today. Thank you for having me at DevSecCon. So today I'll be talking about how to implement zero trust authorization using the Open Policy Agent, which is an open source project developed by Styra. I'm Adam. I'm a solutions architect at Styra, so I work with Styra's customers on how to implement the Open Policy Agent, zero trust authorization, and our commercial product. So let's jump into it. How do we get from first of all, to just start easy on this? How do we get from authenticating a user to actually authorizing them and deciding what kind of permissions would they have to our application? Our application today will be the Superbank backend, where customer support agents can log in and help Superbank's customers with their daily problems around their banking. So authenticating a user is a problem we have solved pretty well, actually. We have SaaS services like Auth0 and many others who manage our users, or we have internal users in LDAP servers, in Active Directory, etc. We can build single sign-on mechanism, so users don't have to have different passwords to different systems. But ultimately, these users, once they have authenticated, they will come and access our system. And usually it's not just about whether they do or do not have access. So our system will have a set of permissions, and our users, once they authenticated, will know some things about them. So our set of permissions in the Superbank backend will be, and our user here is not the end user, but the customer support agent, in this case, Agent Brown. Agent Brown, we need to decide whether Agent Brown can view an account, can list the transactions on a bank account, or whether he can block the bank account. And let's say for Agent Brown, the answer to this question is yes, yes, and no. Now we'll have another agent called Agent Smith, who will actually have for whom the answers will be yes, yes, and yes. Agent Smith can do anything, while Agent Brown cannot block an account. Now, how can we model this situation? How can we manage these permissions and the different rights the different users have? First of all, we can categorize our users based on level of seniority. So let's say a level 1 customer support agent will have different rights than a level 2, and a level 2 will have fewer rights than a level 3 customer support agent. This way we'll simplify our lives to a degree. So we can, once we assign certain permissions to a level, we can also assign certain users to that level, and then those users will have those permissions. Let's make it a little bit more complicated. And let's say we have our bank is operating in the EU and the US, and our agents will be local. So an EU agent can't access US accounts, and the US agent can't access EU accounts. So now we have two different attributes, both on the level of the accounts and our users, to utilize for our system. So first and the most common way to handle this is RBAC, or role-based access control. In this in this authorization scheme, the permissions that we want to assign to users will be grouped into roles. So in this case, level 1, level 2, and level 3. And then users would be assigned to these roles. So through the role, the user gets the permission. So let's say a level 2 user would get account details and account transactions, but there is no line to account block. But for a level 3 user, they get all three. So role-based access control is really good. It's simple. It's easy to understand. And there can be another indirection where users would be grouped into groups, and then the groups would be assigned to roles, etc. We can make this more complicated for managing large organizations. So this is a very popular way of doing things. The tricky part with RBAC is that this scheme here is already, there are a lot of lines, but we still are not actually taking into account the location of the accounts and of the users. So we would have a lot more accounts. And now that means we also need a lot more roles. And this is called the role explosion of RBAC, where companies often end up with thousands of roles, and then suddenly they become more and more meaningless. Like, what does EU level 3 mean? Imagine if we would add 2 more attributes, then suddenly we have like a really higher complexity there. But we have other ways also to handle, and this is not to say that RBAC is not great, just that it has its limitations. So let's take a look at another scheme called ABAC, or attribute-based access control. In this scheme, we don't try to group things into roles, but rather just look at the attributes of users and the resources they are trying to access. I actually forgot to list the location here, but yeah, let's take a look at this this picture rather. So we could say that our users have 2 attributes called a level and a location, and our permissions also have 2 attributes, a level and location, and the user's level attribute has to match the permissions level attribute. The end result of this is very similar as what we got with RBAC, but handled in a more, let's say, logical or more extensible way. Because if we would add more attributes to our users or to our and to our permissions or resources, then this can scale. We don't need to have a database of all the possible roles of these users. However, what is still a bit clunky in the ABAC model is that the relationship between the user's attribute and the permissions attribute is not entirely clear. Like, it's not an equals. For the location, it is an equals, but for the level, it's actually the user's level has to be equal or higher than the account's level. It's a little bit tricky. It really depends on the system implementing this attribute-based access control, on how it would handle defining these relationships. And this nicely leads us to the next scheme, which is called policy-based access control. I nearly slipped on there on that word, which is the main topic of today's discussion, is policy-based access control, where we basically have a policy language available to define our policies. And this is basically using a programming language that's specialized for defining policies. So it's not like Java, where you could write like anything you want and write to files and etc., but a more specialized declarative language where you can express these exactly the relationships like we said before. Let's say the account/details permission is available to any user whose level is equals or greater than 1. And now we can make this more complex because we now can actually kind of program. So we can also say that we just not just use the level, but we'll also use the current time. So let's say the user can only access account details between 9 and 5 p.m. 17 p.m. doesn't make that much sense, but that's all right. You get it. So we can, because we now have the power of a programming language, we can do more fancy things than just using attributes for access control. That's why I put the time in there. I'm actually not going to use that much today, but just showing that that's an option. What's even more, we can even use data from other systems, like instead of hard coding the opening times in the policy, we could pull that from some other system where we keep track of opening times for branches and use that in our policy. So yeah, and we can also do abstractions. So let's say this is starting to look ugly here, but we can abstract that away. We can say we'll have a we're open rule, and the we're open rule will be defined like this, and we'll be using that in all our permissions. So basically, the relationship between RBAC, ABAC, and PBAC is they are uh, they are more and more expressive. So each contains the previous one. You can basically define everything you do with RBAC in ABAC, and with PBAC you can basically, using the policy, you can implement an ABAC or RBAC system, but a more complex one. You can actually combine ABAC and RBAC, which we often do by pulling in, let's say, RBAC data, some rows from Active Directory, but then combining that with some attributes coming in a JSON Web Token, and combining those in some fancy policy to express what we really want from our authorization. And now implementing policy-based access control, and that's basically the point of the Open Policy Agent. So the Open Policy Agent is an open source general purpose policy engine that Styra developed and donated to the Cloud Native Computing Foundation. So it's well established in the CNCF economy, so Kubernetes and all related technologies like Istio and Envoy, etc. And the programming language that I was already using as a sample is called Rego, and that's how we can express, using the Rego language, we can express policy-based access control rules. And the Open Policy Agent will be the agent that actually executes that code and makes the policy decisions whether some action is allowed or not. So the ecosystem is pretty big already and growing. A lot of projects have integrations with the Open Policy Agent, because OPA itself cannot stop something from happening. It has to integrate with some piece of technology that it will make decisions on behalf of. Yeah, so here are a bunch of use cases. Actually, like the categories are interesting. So like application authorization, infrastructure, cloud, etc. A lot of different things that you can use Open Policy Agent for. So now let's jump into Zero Trust. By the way, I forgot to mention it in the beginning. There is going to be a practical demo actually showing how this all works. Let me check how I'm doing with time. Pretty good. All right. So once we cover Zero Trust, there is going to be a demo. Don't leave. So Zero Trust. Very important principle in security that we're trying to achieve these days is our systems are growing more and more complex. So we can't afford anymore to just have one gateway into our system where we check the user, they look okay, and from then on we just allow them to roam our systems freely. We actually want to distrust every single call that is made over our networks, whether coming from an end user or from another service on behalf of some user or on behalf of some automated process. And now we have very good technologies to achieve this. On one hand, microservice architectures allow for many more things to become network calls or even force that. So things that previously were just function calls inside the monolithic application are now actually network calls between different services. So we can and have to verify those for and authorize them, so that one service calling another service will not have full access rights to the API of that other service, but just have actually very minimal rights to perform its own duties. Like, for example, in this picture, We have a user accessing different backend services while they're, of course, in their browser. But we also have the status service, and the status service can access all services, but only a certain endpoint that will return the service's status. So the status service doesn't need the same rights to these services as the end user. And here is the architecture diagram of how this would actually be implemented using Istio. So we need a service mesh, or we don't necessarily have to have a service mesh to implement this, but it helps tremendously for several reasons. A service mesh will inject an Envoy proxy in front of every single one of our services. So all traffic reaching the service, whether from another internal service or from an end user, will be going through the Envoy proxy. Now we can add another component here and add an open policy agent next to the Envoy proxy and tell the Envoy proxy, configure the proxy to make a call to OPA on every single request and ask OPA whether that request is allowed. And with that, we have a fully fledged authorization system where our authorization policy is loaded into every single agent that's running in our system. And every single request that is going through our system will be handed off to OPA for authorization. So OPA is not really a proxy. The request doesn't flow through OPA. OPA can't stop it. But Envoy will actually make an authorization call to OPA, and OPA will say yes or no. And if it says no, then Envoy will send back a request denied response to the client. And all this happens without our microservices having to even know about it. At certain points, they have to know because of some more business logic-y complex authorization scenarios. But for a lot of stuff that we'll be doing today, they actually don't need to know about this. Another aspect here on this picture is the spiffy IDs. Something that also Istio helps a lot with is whenever we want to authorize traffic between internal services, we actually have to know their identity. And that means we have to somehow assign identity to them. We need to verify that the request really comes from that service, etc. And Istio takes care of that using spiffy IDs. So basically, just each request will be identifying the service it's originating from, and this is destined to. The final thing here is the JSON Web Token. So JSON Web Tokens, once user authenticates, this is also not a necessary component, but a very popular way of encoding user information. So once the user logs in through some single sign-on technology, we will be using Keycloak today, then they receive a JSON Web Token that contains basically their attributes for some nice attribute-based access control. And this JSON Web Token will be signed by our authentication system. Will mean we can trust the data inside it. And it will be included in every single HTTP request as in the authorization header. So whenever we receive a request from the user, we can decode this JSON Web Token, get the user's attributes, and use that to make an authorization decision. And this is the system that I'm going to be showing today, the Superbank backend. And I'll show how this all works in practice. Before I do that, one last thing to mention is how does a policy pipeline work? Because when we use OPA to verify a request going to the application, we also have to get the policy into the OPA. And OPA can be configured using a remote policy server, which in our case will be an S3 bucket, a Google Cloud storage bucket. Or we could use some sophisticated commercial system like Styra's declarative authorization service to manage the policy bundles. And normally we would store our policies in Git, have a pipeline that pushes any policy changes to the bundle server, and then all our OPA agents running in our system will be pulling the policies from there. We'll see that in a moment. All right, so it's demo time. Let's just switch to here. And let's go to Superbank, which for some reason is not running. That's not a great thing because it should be running. And it was a moment ago. Oh, let's see what's up with my Kubernetes cluster. Pods are up and running. That's even worse. If they were not, then I could just try to start it all up. Let me just think there for a moment what could have suddenly gone wrong. Maybe I will just straight away restart. That's gonna take too much time, so that's also not a great option. Try to restart the gateway. Actually, it hasn't happened to me in a while that my demo didn't work, but maybe today is my bad day. Okay, it is up and running, but still nothing. $32,298 localhost. Oh, jeez. This is part of the demo. Oh my God. I'm so sorry. I decided the last moment to start the demo with like a completely not authorized application because this is a not authorized, and I thought it's like a 404 or something because I had a lot of trouble with like sometimes the app just not working. So no, now we are absolutely not authorized, and let's start giving ourselves some permissions to this application. So actually, here we go. Here is our policy. And right now, our policy basically, because everything is commented, is allow false. So we are not allowing any requests to our application. So let's do some uncommenting here. And actually, we don't have much time, so I'll not do the step-by-step uncommenting. I'll just uncomment everything and rather walk you through the application. So now I'll be deploying some new policy, which means I'll just build a bundle, which is just a zip file basically of all my policy files, which is the most important one is this one. This is a Rego file. This is the Rego programming language for OPA. And I pushed it to the Google Cloud Storage bucket. And now, yes, now the application actually works. Awesome. So I'll log in as Agent Brown. And Agent Brown is a level 2 customer support agent in the EU. And Agent Brown will be able to view a Dutch bank account, but he will not be able to view the transactions on that bank account because he's only a level 2 agent, and he will require level 3 clearance to see the transactions on the account. Now, trying a California bank account, he can absolutely not see that because his region doesn't match the account's region. So now let's take a look at Agent Smith, who is a level 3 agent, and he actually can see the transactions, and he can even block the account, which by the way doesn't really do anything, but just renders there the button. So we can see that we have different permissions, and let's now take a look at how these are implemented. So we have a bunch of rules here that all make certain allowances. Basically, we have by default we are denying any request that we don't make an exception for. So our first exception is any requests to the portal service, which is basically the service that just returns all the static assets to the client, are always allowed. So static assets can be accessed even if not authenticated. The same goes for the status service. So the status service, as status is okay, it queries all the other services to produce that message. And then we have the permission service, which actually renders these three buttons. And that one needs already a decision based on the user's level. So we will get the JSON web token or JOT token from the request. We do some parsing here out of the authorization header. And so basically our next rule is, if the destination is the permission service, we need to have an authenticated user. If the user has a JSON web token, then they're authenticated. Now, if the user wants to be able to access the account service, we have a few more conditions that need to be satisfied. So the path that if the user is accessing the path that is account /v2 / some location / some account number / details, we can see that that here. How does the request really look like? Oops, I had a breakpoint here. And we go network tab. So the request looks like account /v2 /eu /nl, the IBAN of the bank account / details. And in this case, we want three things to be satisfied. First, the user has to have the customer support role in their JSON web token. They have to have role level of at least 2, and they have to have their geo region needs to equal the location we got from the, so I call it geo region in the token, but location in the path to make it a little bit more confusing, but that's the EU-US thing. Now for the same type of rule goes for the transaction service, where I'm defining customer support role again, but the level needs to be 3. Everything else is exactly the same. Then I have some rules that define that. So when I'm asking actually for account details, the account holder and the address comes from the account holder service. So we make an allowance for the account service, that the account service can access the account holder service. Can actually try to comment this. Deploy a new policy bundle, and actually takes a bit to for the policy bundle to propagate. But once it does, yeah, now you can see account holder is unauthorized. And we also made another rule for the status service. So the status service can access anything, but only the /status endpoint on any other service. So that is it. This is our rule set, and this rule set will be deployed to every single service by just uploading it to this Google Cloud Storage bucket, and will be used to authorize all requests coming into our application. And with that, my time is slowly over. So thank you very much for listening. I think we don't really have time for any more questions, but I'll leave that to the organizers. You can find me on Twitter under ndor with a 0 at the end, or on the Open Policy Agent Slack. So feel free to reach out with any questions. I'm very happy to. And thanks for listening today.